Determine if the system of linear equations is inconsistent or dependent. If dependent, find the complete solution. First, we obtain an arithmetic matrix for the system of equations. 2x, negative 3y, negative 9z equals negative 5. 1x, 0y, 3z equals 2. Negative 3x, 1y, negative 4z equals negative 3. First, we interchange row 1 and row 2 to obtain the non-zero entry 1 in the first row. We take the second row and move it to the first row, 1, 0, 3, 2. And we take the first row and move it to the second row, 2, negative 3, negative 9, negative 5. The third row is negative 3, 1, negative 4, negative 3. The goal is to turn this matrix into a row echelon form or reduced row echelon form by turning the entries in the diagonal into 1. So we first need to turn the entry 2 in the second row to 0 and the entry negative 3 in the third row to 0. We can perform the row operation negative 2 times row 1 and add to row 2 to obtain the new row 2. If we take negative 2 times row 1, we'll get negative 2 times 1, which is negative 2. Negative 2 times 0 is 0. Negative 2 times 3 is negative 6. Negative 2 times 2 is negative 4. And row 2 is 2, negative 3, negative 9, negative 5. Adding column-wise, we'll get 0, negative 3, negative 15, negative 9. And this will go to row 2. To save a step, we can also take 3 times row 1 and add to row 3 to get the new row 3. 3 times row 1 is now 3, 0, 9, 6, and row 3 is negative 3, 1, negative 4, negative 3. Adding column-wise, we'll get 0, 1, 9 plus negative 4 is 5. 6 plus negative 3 is now 3. Thus, we obtain an equivalent matrix. The first row is 1, 0, 3, 2. The second row is 0, negative 3, negative 15, negative 9. And the third row is 0, 1, 5, 3. This is not a row echelon form yet. Observe that if we take second row and divide it by negative 3 or negative 1/3 times the second row, we'll obtain 0, 1, negative 15 divided by negative 3 is 5, and negative 9 divided by negative 3 is positive 3. We keep the first and the third row. The first row is 1, 0, 3, 2, and the third row is 0, 1, 5, 3. Observe that we now end up with 2 identical rows. We can take row 2 multiply negative 1 and add to row 3 to be clear. If we take negative row 2 and add to row 1 to obtain the third row, then the third row is 0, 0, 0, 0. And we keep the first 2 rows, 1, 0, 3, 2, 0, 1, 5, 3. The third row implies that 0z equals 0 or 0 equals 0, so z can be any real number. Z is free to be whatever it is. This is a system that has infinitely many solutions because there are infinitely many z. We let z equal t if z equal t, the second equations tell us 1y plus 5z equal 3. But since z equals t, t is a real number, then y equals negative 5t plus 3. And from the matrix, the first row states that 1x plus 0y plus 3z equal 2, but z is t, so x is therefore negative 3t plus 2, where t is any real number. This is the complete solution where the system has infinitely many solutions. We say that the system is dependent.